Morning, class. Morning. The last time we talked about vertical projection, right?
Yes.
So today we're going to discuss what? Horizontal projection. Today's date is what? 12, 11, 2024. So let's see. You're not writing. You're not ready for the class. Done? Alright, when we talk about horizontal projection, there are so many things you must consider. Like what? When you throw an object, normally when you throw an object, it's going to move and make this shape. Right? That's what you say to me what? Parabola or trajectory. This is part of the projectile. But when you are considering horizontal projection, that means you are standing on something. For example, this is a building that has height. Now, somebody is now standing here to project. Okay? When you project a stone, the stone will now move this way and return to the ground. We consider that as horizontal projection. Do you understand? Because our normal projection will start from the ground and return to the ground. When we are considering horizontal projection, we are standing on something that has what? A certain height. So we are considering height when we are talking about horizontal projection. Is that clear?
Yes.
Okay? So in horizontal projection, so many things we put into consideration. The height. Okay? Then the time to reach the ground, and also the horizontal distance, which is said to be what? Range. Do you understand? In horizontal projection, you don't consider the time to reach vertical and time to return. Now it's not going vertical, it's just coming what? Down. And we are using the equation of motion under what? Gravity. Now let me do a sketch and explain further with it. That's it. Sketch. Let's do sketch. Support Keshiku, thank you for coming. Ijabo Onyeka, good morning. You're welcome to today's class. Nakuzi Onyeka, thank you so much for coming. All right, copy fast. Let's proceed. Fast. Lozia Foodies, good morning. You're welcome. Thank you for stopping by. Are we done?
Yes.
Alright, so when we are considering horizontal projection, I said that we are going to consider three things. One is what? The height. Because the object, the person that will project the object is standing on top of what? A certain height. Let me say a height of a building, height of a tower, anything that has a Alright, then this ux means horizontal what? Velocity. We are going to be using the equation of motion under gravity. And let me do a recap of motion under gravity. Let me do a sketch here. If an object is going up, it is moving against the force of what? Gravity. So A is equal to minus what? G. And final velocity is equal to what? 0. But if an object is coming down, it is moving towards the force of what? Gravity. Our A is equal to what? Plus G. Then U is equal to what? 0. Now, if you are comparing this with this motion, you see that I'm taking the what? The downward motion. That means this object is coming what? Down. And if object is coming down, that automatically means that U equals what? 0. Is that clear? Okay. Then using this equation of motion, which says that what? H is equal to ut plus or minus half gt what? Square. Now, if you are considering the downward motion, my initial velocity equals what? 0. From this, right? Then if u is equal to 0, that means ut is equal to what? 0. This one is equal to 0. Then there is a plus because the object is coming down. It also means that h is equal to half gt squared. Do we understand? And the question is, how do you know when to use this equation to solve? Because it does not have angle. You are going to use this equation to solve when the question is specified. And the question will be specified. For example, an object is projected horizontally. Once you hear that word horizontally, that means you are working with horizontal projection. You're not going to use the other formula for what? Projector. Do you understand? Okay, so this is our first equation for height. Now the next thing, you can also find your time here by making t the subject. By the time to make t the subject, what do I do? I'm going to say h is equals to half gt what? Square. Right? This half is the same thing as 1 over 2, right? Right?
Yes.
And I say this is over 1 cross what? Multiply. That means 2 what? 2h. 2h, right? Okay. By g. So my t square is equals to 2h over g. But because I want to find g, or rather make it the subject, I'm going to do what? Take the root of both sides. If I take the roots of both sides, I'm going to cancel this, right? So this is what? T is equals to root of 2h over g. So this is the formula for time under horizontal projection. Do you understand? Okay, put it down. Let's solve for the last one, which is what? Range. Are we done? Are you seeing from there? Now, if I That's what is range. Horizontal what? Distance. Horizontal what? So what is distance? Or what is speed? Speed is distance over time, right? If I say that speed is distance over time, so what is distance? That is speed times what? Time, is it not? And my horizontal distance, okay, let me say d is equal to speed. And speed is what? Let me bring it down. Speed times what? Time, right? But the horizontal distance here is said to be what? The range, which is r. Is equal to what's my speed? My speed is my initial velocity, ux, then multiply by what? Time. So the formula for range is uxt. The question is, why is this x there? Why did I put x there? Why is the x there? Look at the direction of the motion. Why is the x there? The x is going in the horizontal direction. In a normal projection, we have what? Vertical, uy, and u what? Ux. So this one is for horizontal motion. This one is for vertical what? Motion. Okay? Alright. Are we done? Fine. Have you seen this? Okay. So the three things we should consider under horizontal projection. One is what? The height. Two is what? Two is what?
Time.
And three is what?
The range.
Right? Okay, so let's look at a few examples. Are you not writing? So let's solve an example. All right. Okay, let's solve. Are we done? Alright, so let's work together. Every what you have on the board.
The ball is projected horizontally from the top of a hill with a velocity of 30 meters per second.
Meters per second.
If it reaches the ground 5 seconds, calculate the height of the hill.
Now, this question is specific horizontally. Okay? So you don't need to use the other formula for projected slope. Right? So we are giving so many parameters, we are giving them velocity u to be 30 meters per second. And what again? Which is 5 seconds. Right?
Yes.
And what are we looking for?
Height.
What of G? G should be constant, right? 10 meters per second what? Square. Now what's the formula for our height? H equals what?
Half GT.
Okay, so we say that H is equals to half GT squared. The question is, why are we not using U? Even though we are giving you the question. Yeah? So why they give us U? They just give us U so that we know the speed at which the object is being projected, okay? But in the formula, you're not using U to solve it. It's like you're looking for range. You cannot use velocity. So let's go. This is half times. My G is what? And my time is what? 5 square, right?
Yes.
That is H is equals to 1 over 2 times 10 times what? 25, right? So can 2 divide itself? Can 2 divide 10?
Yeah.
So I have 5 times 25, Abby. So what do we have? When you multiply, that side becomes what? That side becomes what?
110.
Yeah?
110.
You say 110. How do you get your answer? So that side is 125 meters. Okay? Alright. So copy fast. Let's do more examples. Are we done?
Yes.
Okay, so let's look at the next question under that. Actually,
Yes.
are you done?
Yes.
Example 2. Alright. So copy, let's solve. Are we done?
Yes.
Be stating your parameters. Let's see whether I have an idea of what's going on. What's that? Is it the pin that you are bending? Like, what's your problem? Eh? How is it pin to do anything this morning? Shit. No, we need to do that. State your parameters, baby. Let's see whether I have an idea of what you want to do. Are we done? So, can we read the question, everybody? Yes? Can we read?
A particle is projected horizontally
Like you're not eating this
10
morning.
meters
Are you
per
not eating
second.
this morning? Please read the question. I'm hearing you clearly.
A particle is projected horizontally at 10 meters per second from the top of a tower 20 meters high. Calculate the horizontal distance traveled by the particle when it hits the level ground.
What happens to this? G equals what?
10
10
meters
meters
per
per
second
second squared. Okay, so let us set our parameters. These are horizontal velocity, which is ux. You can still keep it as u, it's still fine. Okay, it's given as 10 meters per second. Right? What again is given? The height is given as what? 20 meters. What are we looking for?
Range.
Which is the horizontal distance. So we're looking for what? Range. 10 meters per second squared. Okay? Now, for us to get the range, the formula for range R is equal to US what? Z. But do we have T? We don't have time. So we're going to find time using our what? Height. Remember that H is equal to half GT what?
Yeah.
Is it the time for height?
Yes.
What are the time for time?
The different time is 2H over G.
Okay, let's see the same thing. Just like make this subject. Okay, let's do that one straight. C is equal to root of what? 2H over G. Right? Okay, let's substitute. So we have T is equal to, this is 2 times, what's my H? 20 divided by what?
Divided by
10.
G is 10. Okay? Then this can cancel this, right? Okay, so 2 times 2 is what?
4.
So root of 4 becomes what? And it's 2 seconds. We can now put it here. Right?
Yes.
To solve our range. So range is equal to USP. What is my U? My U is what? 10 multiplied by what? 2. So when I multiply, I'm going to have what? 20. Like that seat is not good. I want to spoil it. Need to get another one. 2 times 10 is what?
20.
20 what? Okay. So that is how we get our rate. You can see that in this question, they want you to have the knowledge of what? And when you get the time, you now apply it here to get what? To get the rate. Yes. When you sit, you not sit well. You be shaking the chin. You sit well. With all of this, if you want to spoil everything, how can you sit to be good at it? Like, if that's good at it. This was not like this. You don't sit and sit properly. Now I'm going to give it what you're going to try for me now to see what you have. Are we done?
Yes.
Please still writing. You are still writing. You write fast. Are you done? You are done. Okay, so try this one. You go to your seat. Okay, so look at the question and see if you can attempt it. You actually have to find two different things. So see if you can attempt. Are we, are we, why are you giving him? Why are you giving? Why are you giving him? Why are you giving this one to them to just copy? All right. So who will stop it for us? Who will stop it for us? I'll correct you if you mistake. Don't correct. I'll correct you if you mistake. Don't correct. I tried. Where is calculator? People will tell him, oh yeah, starts. When it's time to calculate.
Shut up.
Now your light is not visible. I feel like 70. Use this marker. What failed? Take the calculator. Alright, can you explain what it is? Explain. How will they understand what it is? So who will explain? Yeah, explain. Who will explain?
Questions. Our height is 90 meters. And we're looking for time and distance. Our velocity is 50 meters per second. And our ground is constant 57 meters per second. And according to the formula, to find time is 2h over g roots. So, and our just put 2 times h, which is 90 over 10, which is our constant. Going to give us 18 in 5 square, then to give you 4.24 seconds. And to find this, yes, to find distance range, according to the formula is uxt. So we times 50 with our seconds, 4.24, and give us 12 meters.
Happened easy. But do you understand what you're saying?
Yeah.
So it's just like the one we saw last. They're giving the height of 90 meters and we're looking for the time. We're going to use the height to get the time, okay? Then when we are done, I'm going to use our time and put it here to get our what? Horizontal distance. So my time is up. The next time I'm going to do, the time is coming up. Is it next week?
No,
Yes.
it's
25th. That's upper week. Okay, so if I next week we do our revision. Alright, call us as one student. Everybody is when he comes for you. Who is
yes.
or you can call us as one and tell me the time that their own period is end. Their own period. When is the period ending? Is it a single period? They have adjusted the time table. I'm not aware.
Move from there. Serious.
Can I see your physics note? Alright. No, no, no. Settle down. What of your mate?
You're on your way. What's the last name?
I don't know. Send it to
Did you see it?
Yes.
5 is 6 now.
Settle down. What's the problem? I don't need somebody here. This push is too out. Stay here. Don't stay here.
I'm already staying.
Smile on his face. Inside that.
Who is there? All right. All right.
Sorry. None knows that it's true.
So the last time we talked about what?
Let's talk about non-contact and contact.
What are contact forces? So we are going to
That's the little. That's the little.
no. Stop. Are you done?
Yes, please.
So this is what you have.
Friction is defined as the force which acts at the surface of separation between two objects unless there is relative motion or a force steady to produce motion. Frictional force also continues to act as long as one body moves over.
Two bodies coming in contact because they are not also an example of what? Contact force, right? An example of what? Contact forces. So when if you rub oil and your two hands, if any oil, olive oil, any oil is oil. Your hands will be slippery, right?
Yes.
Okay. Now friction cannot act on such body because the both bodies are what? Smooth. So we need two bodies. One will be rough and one is what? Smooth. So that friction cannot take place.
But like our shoes too.
Your shoes will be smooth. The ground where you walk on is not rough. So that is why you can easily walk without falling.
No, I have a question. What? No, I have a question.
One must be smooth,
I have
yes.
a question. What if a car is driving and low car engine like black, like black, now screw on the road? What if eventually the car pass over like much It's question now.
It's you. But the two surfaces are what? They are smooth, right? Be in what? Contact. Must be in what? Before it can come into play, right? In as much as there is relative motion, there must what? There must be friction. What is relative motion? This body is going this way. Friction is opposing this motion. You understand? We are going backward and she is going what? Forward. So that is the friction. They are not acting in the same direction. Do you understand? Yes. We are moving this way. The friction is drawing you what? Back. Can you walk on your bare foot? Can you walk on clay soil with your bare foot?
No.
It will even be possible for you to walk.
It will not be because I will be trudging in it.
Yes. Because the clay soil is what? Smooth. While your bare foot is what? Smooth. Do you understand? So we need the two surfaces. One must be rough, one must be what? For friction to go into that. Okay. You have types of friction, static and dynamic what? Friction. There's no noise. Now let me sketch this. Yes. look at a sketch of what friction is all about, which is the force of what? Opposition. Now, if somebody is dragging this with an effort means that is the direction of where the motion is going, okay? Let me say this is direction of motion. Somebody is dragging it this direction, okay? Friction, which is the force of opposition, is going to take it to the opposite direction. Do you opposite direction? So we have two types of friction, which is static and dynamic force friction. All right. Copy what is on the board, please. Are you not writing? Are we done? Are we done? Almost.
Yes, sure.
Sign. As what now? What's the meaning of that? Am I not? Right. We have two types of friction. I will explain that diagram. We have static or limiting friction. I see right. So let me explain from here again. Dynamic or kinetic what? Friction. What is static or limiting friction? It's the maximum force that must be overcome before the body can just start to move over what? Another. Okay? Now, for this body to move over another, or for this effort, which is the body, this block of wood, for you to apply your effort on this and it move over this body, which is a smooth surface, you must overcome one static or limiting what? Okay? Now, what is kinetic? Is the force that must be overcome so that the body can move with uniform speed over what? Another. Kinetic means the body is already in what? In motion. So for the motion of the body to be uniform over another, you must do what? You must overcome kinetic or static what? Friction. This one is before the body starts moving. But this one is when the body is already in what? Motion. Okay? So in case I ask you to distinguish between static and kinetic what? Friction. You should know the difference. Is that clear?
Yes.
Okay, next I'm going to look at is laws of solid friction. Laws of solid friction. We have 5 laws, so let's start with the first one.
Clean the restroom.
Okay. You're not writing. What's that? Are you done?
Just leave it.
Copy fast. Are we done?
Yes. Move on.
I'm going to explain the laws of friction. Let me stand here so that you can see while I'm explaining. Number one, frictional force of friction opposes the relative motion between two surfaces in contact, right?
Yeah.
I already explained that.
Yes.
That the two objects or surfaces must be in what? In contact too. And they must move in the opposite what?
Direction.
So their motion is said to be relative, right?
Yeah.
Okay. The force of friction increases to the same extent as the force which tends to start what? The motion. Now, the force I want to start the motion is the force that is going this direction. Okay? So it's of the same extent with the force of what? Friction. That means they are equal to each other. Number three, frictional force depends on the nature of two surfaces in what? I said it. You cannot bring two smooth surfaces and say that friction will take place then. You cannot compare it with a rough and a smooth what? Surface. Then number four, it is independent of the area of the surfaces in what? In contact. Even though the surfaces in contact must be there for the friction to take place, but it does not depend on the surfaces in what? In contact. So the last one, are we done?
Yes.
I'll refer to it. You hear me?
That's good.
Alright. So I want to explain this fifth law so I can understand better. Then this period ends by what time? So I just said the time. It's not that.
So
It's what?
After physics,
So I said the time.
it's 12.
it's 12 now, because
What time is your
We
break?
don't have before break. We have
What time is your break?
we don't have break. 63 without break. Maybe 63 without
Alright, so let's proceed. Okay, now no noise. It varies directly with the normal reaction pressing the surfaces together. That is, it is proportional to the normal reaction what? R. The frictional force F is proportional to the normal reaction what? R. And what is the reaction force? Reaction force is equal to the weight. That diagram I gave you,
Yeah.
that's like this, right?
Yes, yes.
Now this is the weight going down,
And
this is the reaction acting up. So reaction is equal to the weight. And what is weight? Weight is mass times what? Acceleration. Reaction is equals to weight, and weight is equals to what? Do you understand? Okay, so remember in every proportionality sign in physics, you must remove it and introduce a what? A what?
You must remove it.
Proportionality sign and introduce a what?
Constant.
A constant. So F
F K.
is equal to, we don't use K all the time, so I'm going to use mu. It's just
Okay.
like when you write U, you just extend it, right?
Yes.
Now this is a constant. This is constant. Where F is frictional force. That is mass times linear acceleration. R is reaction force. That is M what? Mg. I'll explain the difference. Then mu is coefficient. Coefficient of limiting what? Limiting friction. Now I want to explain why this frictional force is Ma and the reaction force is Mg. Now this frictional force is the horizontal force. When the object is moving the horizontal but in the opposite direction of the motion of the body. Right? So it's going with horizontal acceleration, which is A. But weight is acting what? Down. And it's moving with the gravity, which is what? G. That is why this reaction is Mg, whereas frictional force is M what? A. Do we understand? Do we understand?
Yes.
Wow. I'm going to solve a problem with it. Are you done?
Yes, ma'am.
So I'm going to bring one example that will solve. You are still writing. You are done. All right. Question. A wooden block of mass. A wooden block of mass. Are you writing? Are you writing?
How do you say?
A wooden block of mass. This example. One point 6 kilogram rests on a rough horizontal All right, copy. Let's solve. It's not even just read like it. Pass it. All right. Can we proceed?
Yes, ma'am.
A wooden block of mass 1.6 kilogram rests on a rough horizontal what?
Surface.
If the limiting frictional force between the block and the surface is 8 Newton, right?
Yes.
Okay, calculate the coefficient of what?
Friction.
And we're giving G to be 10 meters per second squared. Now, if I use a sketch to explain this, I have this. Okay? And then it's not going.
Horizontal. Is it like that? Horizontal is straight. It's straight.
My bed.
Give me meter rule, please.
Wait, give us the clue.
Yes. All right.
Yeah.
Okay. I have this. Right? This is the block of what? Mass. Right?
Yes.
You are not talking. I don't know whether it's still so you.
No, mathematical.
Okay, they gave us the mass. They gave us the mass to be 1.6 kilogram, right?
Yes.
And they gave us the frictional force, which is 8 what?
Newton.
8 Newton. Now, how can we get the coefficient of Newton friction? Remember that R is equal to weight, which is equal to energy, right?
Yeah.
My mass is what? 1.6 multiplied by my G is what? 16 what?
Newton.
16 Newton. So for me to get the frictional force is already given as 8. From the formula, the frictional force is equal to mu what? R, right?
Yeah.
That is 8 mu what? Times 16, right?
Yes.
And if I want to say about the coefficient of mu, which is 16, then my mu
It's 1/2.
is
1
1/2, which is
or
what?
0.5.
0.5. Okay? So this is the coefficient of limiting friction.
My Z was 1.6 euro only was 8 equals to new
Which one?
solution. 8 equals to R better than N times this is 2.
1.6.
Is it this one?
Yes.
It's 16 now. I'm talking 16. I think this is 16 as well. Are we done?
Yes.
Do you have questions? Let me give you one to try for me. You are not here. What happened to you? I'm going to give you similar thing for you to try. Question. Copy. Want to dictate the question so that we can please. I will try this one.
Okay.
A force of 20 Newton.
Yeah.
A force of 20 Newton applied parallel to the surface of a horizontal table. A force of 20 Newton applied parallel to the surface of a horizontal table, comma, is just sufficient to make a block of mass. Is just sufficient to make a block of mass 4 kilogram. A block of mass 4 kilogram move on the table. Is just sufficient to make a block of mass 4 kilogram move on the table. Full stop. Are we there?
Yes.
Calculate the coefficient of friction between the block and the table.
Coefficient.
Calculate the coefficient of friction between the block and the table. And G is constant. G is given as what? 10 meters per second square.
Should I?
Yes.
Yeah.
And
G is 10 meters per second square. It's part of the question. This is the same method of what I just did. And so we're going to get the answer.
is constant.
Where the value of G? Where did it? That boy. He has destroyed one. I don't understand. Why not allow him sit here again? Use the formula we just used and apply it. You're going to get the answer correctly.
And of course,
I've got my answer. Oh, I've got an answer. I've got my answer.
What's your answer?
0.5.
The boy, what's happening?
And that's equal.
Use the same method.
What is that?
Okay. You, what happened to you? You don't never answer. Even you.
now
You never said that. This is frictional force. This force is frictional force. And again, two mass. This mass is for this one. Multiply by I'm asking you. Do you understand? But that was not the previous one. The same thing, like this is the friction, 20 Newton. They give us the mass of multiply I did to get the book. Yeah.
Because that's what I
All right. So who solved it for us? Come on, sir. You clean the board.
Hey, sorry. Yep. Clean the board. They clean the board and right. Like, I should write questions. Mark of salt.
Okay, please, so you can solve for us.
Mama correct. Mama correct.
What's that?
Wow. That's the song you watch there.
You know she's supposed to be F, not 20. Is
Yes.
it not F? 20 plus a new R is 40.
What time?
The one that made a mistake. What is it? Why need to raise it up?
So
Raise your bell up, yes. So they can see where.
my question answer.
The answer is not.
0.5.
You see, I get your answer. What did you get? Cassie or 20 and 40.
She correct?
Yes, ma'am.
Give her a sound clap. Alright. So your assignment for today. Assignment, yes.
But this is not get the assignment. Just like this.
You send my notes now.
I know what you got to do.
I will just explain when I see you again. Advantages. It's in your notes. So use this step and do that.
So you got that.
The advantages of friction. Outline the disadvantages of friction. Okay? And the last one. State the ways of reducing friction.
Yes, ma'am.
All right. I'll see you next time.
See you.
Okay, bye. We are come to the end of this class today. Thank you so much for staying to the end of this class. I hope you enjoyed the lesson. I will see you next time in the next one. Bye.